Okay, welcome to today's live session in NG Asia. I'm excited to have you here for every special conversation with Sonu Kapoor, Angular GDA, and a passion educator in Angular ecosystem. Today's topic: signal forms in Angular, es- escaping event-driven form, and returning to scale to the state. Sorry. In this session we will explore how modern Angular is evolving with the signals and what that means for the way we build and manage forms. For years many of us have worked with the event driven pattern, subscribing to value changes, handling outputs, and reacting to streams. But with the signals, Angular is shifting back towards a more explicit state-driven model. So make sure to drop your question in the chat and let's dive deep into the future of the forms in Angular together. Sono, you can start.
Thank you. Let me just quickly share my screen. Let me know if you can see it.
Yeah.
Okay, so you're seeing the presentation, nothing else, right?
Yes.
Okay, awesome. Yeah. Thank you for having me again in your meetup. It's a pleasure to always come back and speak to you about, latest Angular topics. So today I'm going to introduce signal forms to beginners, but I'm going to do it in a way, that respects what experienced Angular developers already know. So as for years, Angular forms meant one thing: reactive forms. And then they were powerful, they were flexible, and essentially they became the default tool for anything beyond like trivial input forms, right? So signal forms are not simply reactive forms with a different syntax. They represent a different mental model. So instead of building a tree framework, classes, and then extracting your data from that tree, signal forms start with your data model as the source of truth and derive the form behavior from it. So my goal today is to make that shift feel obvious. And I want you to walk out understanding why event-driven thinking becomes painful in complex forms, and why RxJS becomes an accidental prerequisite for form work, and also why thinking in form control and form group class shapes how you actually design your software. So we'll also do what beginners need. We'll build a complete example with real code and show how the template stays clean, how validation stays close to the model, and how the result is simply easier to reason about. So before we get started, let me just quickly introduce myself. My name is Sonu Kapoor. I'm a senior Angular developer consultant. I've worked with various top Forbes 100 companies and helped them with their Angular project. And as mentioned, I'm also an Angular GDE and a Microsoft MVP in the Web Developer Technologies category. I've contributed quite a bit to the Angular framework itself, created over 100 pull requests, which got me invited by Google to become one of their trusted contributors. And I'm also one of the core contributors to the NGX layout library, a library that features, directives to allow developers to easily create responsive and adaptive layouts using Flexbox CSS. Okay, so let's start with the part I think everybody or everyone agrees on. Forms are very complex, right? Even a simple form login can quickly grow into something, more realistic. So you add error display rules, you add disabling logic, you add async checks, and suddenly your form your simple form has state, scattered all across the component, the template, and the form definition. So what makes forms uniquely difficult is that they are state heavy and also relationship heavy. So most of what we care about in forms is not that an event happened, okay? So most of what we care about is give me the current state, like what is true? Is the form valid? Is it pending? Should the error be visible? Should we disable submit, or even should the section be shown? So when we build forms in an event-centric way, we naturally end up coordinating chains of reactions. And that coordination is what creates a mental load. So you can absolutely make it work, and we have done this for years, but it often feels like you're fighting complexity that is not actually part of the business problem. So signal forms are Angular's attempt to make forms align with the way we already think about state as a model with derived truths. So here is a subtle but important point, that shapes everything. Reactive forms, they train you to think in Angular's internal abstractions. So when you start a new form, your first thought is usually, do I need a form group? And not, do I need to use a model? So that means you're designing your solution in terms of framework classes. So your domain becomes something you pull out at the end by reading form.value. And that often you end up transforming the value into a shape your backend actually wants. So this class-centric thinking also encourages tree navigation thinking. So you become really fluent at calling get, right? Navigating nested groups or casting controls, and then dealing with nullable lookups or wiring up arrays. So over time, you get good at it, but that doesn't mean that it's the most natural or simplest approach. So signals forms flip this mental model. It says, start with your data model, put it in a signal, and derive a typed form view of it. So that keeps the domain front and center and makes the form feel like a projection of your state rather than a separate system that contains your state. So event thinking is really powerful, but it comes with a cost. When your system is primarily driven by events, the way you debug changes. So instead of asking, what is the current truth, you ask which event fired and did it propagate correctly, right? So in reactive forms, value changes propagate through the tree. Then status changes propagate. Then you have async validators that kick in later and resolve. Template rules read, touched and dirty flags, which are also updated through user interaction and internal state changes. So none of that is wrong, but all of it is inherently time-based. So when something goes wrong in a complex form, the problem is rarely that the rule is incorrect. Problem is that usually you don't know which part of the system updated which piece of state and when. So debugging actually becomes a timeline. You have to inspect, the value changes subscription. You add console logs. You check who subscribed. You wonder if a subscription is still alive. And then you have to try to reproduce the exact sequence. So signal forms reduce the need for timeline reasoning by basically leaning into dependency-driven recomputation. So the emphasis shifts from what happened to what depends on what. And this is where beginners struggle, right? And even where seniors actually get really tired, because reactive forms are not just forms. They are forms plus RxJS. And if you want good UX around async validation, autosave, derived state, or conditional enablement, you end up building streaming pipelines. And you can absolutely do that. You can build beautiful pipelines, but it silently becomes a requirement that anyone touching forms must understand the cancellation semantics, subscription lifetime, operator behavior, all of this that comes with the RxJS package. So in other words, to implement something conceptually like check username availability, you need to teach RxJS. So signal forms don't really remove RxJS from Angular, okay? You still use RxJS for lots of things, but Signal Forms tries to aim to remove RxJS as a prerequisite for thinking about form state. So instead of subscribe and react, the primary mental model becomes declare state and derive the values. So that is a big deal for beginners because it lowers the learning curve, and it matters for teams because it reduces how much specialized knowledge is required to safely change forms. And the biggest difference between approaches is not the syntax, okay? Now, don't get confused or don't get too hogged on that. It is where does the truth live? So in reactive forms, your form controls store your form controls store the truth internally. So what you do is you interact, for example, with the form group and you read values out of it. Your component code often treats the form as the model. So in signal forms, your truth lives in a writable signal. And when you want the current values, you call the signal and you get your model back. So that model is not an afterthought, like in reactive forms, when you do form.value. Instead, this model is your foundation. It is where you start. So once you accept that inversion, other things actually become simpler. So typing becomes stronger because the form is derived from the model shape. Binding also becomes cleaner because fields are accessible as properties. And also validation becomes easier to centralize because you can define it against the same structure you use it for your data. So if somebody asks, why should I switch? My first answer is, Signal Forms put the domain model back in your control. So that makes forms feel like part of your state system and not a separate subsystem that you have to learn. So this is now where I think beginners immediately feel the simplicity. So we start with a plain TypeScript model. We define a type that describes what we care about. Then we store it in a writable signal. So there are no form classes yet. There are no validators. There's no control tree. We are simply stating this is the state of our UI that we should be able to edit. This also really scales well because your model can be nested. So you can represent real domain structure. For example, customer info, shipping address, payment details. And you do not have to flatten your world just to satisfy a form API. There's also a better long-term architecture because your model becomes usable outside the form itself, right? So you can store it, clone it, compare it, pass it to services, and test it independently. The form becomes a view over that model, not the owner. So that is the, I would say, return to sanity moment for many teams, right? You stop thinking about form control as the primary unit and start thinking about your domain object. So this line here that you see is really short, but it's doing something conceptually really important. So we're asking Angular here to create a type form view of our model signal. So the shape of the form mirrors the shape of the model. If the model has nested objects, the form automatically provides nested field access. If the form has arrays, the form, sorry, not the form, if the model has arrays, the form gives you structured classes for that as well. And the key idea here is to emphasize its ownership, right? We're not copying values from the form to the model and from the model to the form. These aren't like two separate sources of truth that we keep in sync manually. The model signal is the source of truth, and the form view stays synchronized automatically. And that synchronization is one of the reasons this feels simpler. So in reactive forms, you often end up, writing glue code to initialize the form, patch values, reset values, and maintain coherence with other parts of the state. So most of the time, you have a type or data, and then you bind that to the reactive forms, right? So here the model is the coherence part. So at this point, we now have a model signal and a form derived from it. Now we can bind it to the UI. So this is where the template becomes dramatically much more approachable, especially for beginners. So we bind directly to the field objects produced by the forms. We do not use form control name. We do not use string pass, right? Like using the get function. And we do not traverse any abstract control tree. We just access loginform.email and loginform.password. And there's an important version note to mention here once, so people don't get confused when they see like blog posts. So in Angular 21, the directive name was called field. And in Angular 21.1, it was renamed to form field. So the concept is the same, only the name changed for clarity. So, but the bigger point is that, the binding is typed and direct. So if you rename a property in your model, TypeScript can guide you to refactor. So you're not hunting string paths and like across templates, right? So this is one of the changes that seems small until you experience it at scale. Typed property access, eliminates the runtime errors and makes your code base more refactor friendly. Excuse me. So this is now where the forms are state systems. So the idea really shows up here. Validation is defined centrally in the form creation call. So you're not sprinkling validation logic across different controls. And you're not building ad hoc subscriptions to enforce rules. The schema callback receives a typed path object that mirrors basically your model shape. So that means validation reads like business rules against your domain, not like plumbing against a control tree. And I also want to call out why this matters for beginners. So in reactive forms, beginners often learn that validators are something you attach to form controls. And then they hit cross-field validation and the mental model breaks. They discover form level validators. They discover parent control access. And they end up confused about where rules belong. So here, the where question is answered right up front. Validation belongs alongside the model shape, and the API is built to encourage that. So now we have validation rules. Next, I want to show you errors in a way that is predictable and readable. So in reactive forms, we could already do this. We could check control.invalid, control.touch in the template. No subscription was required. So signal forms are not really revolutionary because we don't subscribe to show errors. That already worked, right? So the real difference here is the architectural ownership and typing. So in reactive forms, invalid is a property of an abstract control instance that internally like mutates and propagates status changes. In signal forms, invalid is derived from a signal-based dependency system that is tied to your model. So that means the truth originates from your model. The form reflects that model, and the derived state is computed based on dependency tracking. So in practice, both approaches render errors in the template. And again, the difference is not really in the syntax, it's in the mental model, in the mental alignment, right? In reactive forms, again, the control tree owns the state. In signal form, it's the model signal that owns the state. So error rendering may look really similar, but the ownership model is fundamentally different. And again here, let's just look at this honest example. Reactive forms already had form.valid, form.invalid, form.pending. You didn't need to subscribe to those either. So again, what's the point here? The difference is not whether the property exists. The difference is how the state system is structured. And again, in reactive forms, valid is derived through internal mutations inside abstract control. So it follows this event system, right? And you don't control that state model. In signal forms, again, valid is a derived signal, and the dependencies are tracked explicitly. So the important nuance is like reactive forms are internally reactive, while signal forms are externally reactive. Okay, let me repeat that one more time. So reactive forms are internally reactive, while signal forms are externally reactive. So reactive forms hide their internal propagation model, while signal forms align with Angular's broader signal-based architecture. And that alignment matters for consistency across the framework. And so this is actually the moment where reactive forms usually start feeling heavy for beginners. So nesting means nested groups or form groups, nested template directives, and a lot of ceremony, right? People start asking questions like, do I need a form group name here? And what is my nested group null? Why doesn't this validator rerun and so on? So with signal forms, nesting is just nesting, right? We're still writing plain state. We're still describing our domain model. And that model is readable, testable, and obvious. You can look at this model and right away understand the business problem immediately. So this is also where real world forms typically become fragile. Not because nesting is hard conceptually, but because the form abstraction becomes heavier than the model itself. So when we build nested form groups manually, we usually duplicate structure. We wire parents and children explicitly. We think about control state instead of domain state. The deeper the nesting, the more the form becomes infrastructure instead of business logic. And that is a real problem here, right? So signal forms, they flip that thinking. They start from the model and derive the form, not the other way around. We'll try to unpack this more deeply when we look at validation and async checks. So now we'll create a form from it and bind it to the UI. And you'll see that the template stays clean even when the structure grows. So this code here is important because it highlights what disappears, right? So in reactive forms, nesting usually comes with structural directives like form group name and more configuration in the template. So beginners often end up mixing template concerns with data concerns and get confused about where the shape is defined. So here, the template doesn't really do anything special or any special ceremony to navigate the tree. The tree is already defined by the model, and we bind directly to the checkout form dot customer dot first name, right? And that reads like domain code, not like framework code. And this is exactly the kind of thing that makes signal forms feel awesome. You can keep adding structure to your template. It still looks like straightforward TypeScript property access, right? So now we'll tackle the two big pain points where reactive forms often push people into RxJS, conditional UI and async validation. So there's real pain point about subscriptions, right? And the real pain in reactive forms is also string-based navigation of deeply nested controls. So if you have a nested form group like shipping country, like here, that line contains multiple problems. First, you're not going to have any IntelliSense for shipping or country. So VS Code cannot help you discover nested controls because you're using strings. Second, it's fragile. If you rename country to country code, nothing in the template will warn you. You'll only find out at runtime. Third, you get optional changing, right? Every time or everywhere, because get returns an abstract control or null. Okay. And fourth, if you mistype a string, Angular will not catch it at compile time. So this is a serious ergonomic issue in large forms. So typed forms or type to reactive forms were a big step forward, and they deserve credit. They improved value typing and made a lot of unsafe casts less common. But in real code bases, once you have nested groups, people still end up doing exactly this. They grab a nested group, cast it to a form group, because Angular's types don't preserve the precise nested structure in a way that feels frictionless. And then they navigate through the controls tree to get a value. So this is the moment where developers really experience starts to feel like a ceremony again. You're writing plumbing code whose only purpose is to regain access to your model or to your structure. And notice what your brain is doing while you're writing this, right? You're not thinking shipping country. You're thinking controls.shipping as form group, then controls.country. So this is what I call framework first thinking. Now compare that to signal forms. So signal forms eliminate the need for that ceremony because the form tree mirrors your model. So you navigate with normal property access. You get IntelliSense, you get the compiler participate in refactoring. And the difference compounds heavily as forms get deeper and bigger. So this is a fully typed property access. You get autocomplete, you get compile time safety, you get refactor support. This is not about subscriptions. This is about DX, developer experience, and long-term maintainability. So when you have 30 nested fields, this difference compounds. This is one of the strongest practical arguments for signal forms. And it resonates far more than we don't need subscriptions. So this is a very realistic pattern here. Let's break down what's happening. So we subscribe to value changes, we debounce so that we don't hit the server on every keystroke. We call distinct until changed, so identical values don't retrigger. We use switch map to cancel previous requests. We manage lifecycle hooks or lifecycle with take until destroyed. Then we manually call set errors. And this works well. RxJS is doing what it's good at, orchestrating synchronous event stream. But look at the conceptual surface area. So to implement that a user name is taken, we have to understand debouncing, cancellation semantics, subscription life cycle. You have to understand error propagation. And then you have manual status mutations. So that is a lot to ask of someone who just wants to validate a field. Now, the key question here is, how does Signal Forms handle this without forcing us into this pipeline? So let's see carefully what changed here. Instead of subscribing to value changes, we define an async validator at the schema level. The validator receives the current value and it performs the async call. It returns either an error object, or null. So that looks simpler, but the important part is what Angular handles for us. In Angular Forms, the validator reruns automatically when the field value changes. So Angular tracks dependencies. And if the value changes again, while a previous validation is pending, the previous result becomes irrelevant. the form exposes a pending state automatically. So we no longer need to manually subscribe. We no longer need to call set errors. And we obviously do not need to call or manage any lifecycle cleanup. So, but here's a nuance, right? Signal forms does not automatically debounce. So if you want debouncing, you still need to implement it, either in your service layer or by wrapping your async call. But notice something more important here. Debouncing now is an optimization concern, not a form orchestration concern. And the cancellation semantics are handled by the validation lifecycle itself. So again, you're no longer coordinating systems or streams, you're declaring validations. And that is the architectural shift here. In reactive forms, async validation becomes essentially event choreography, right? In signal forms, async validation becomes simply a rule attached to the model. So that keeps the mental model consistent. Okay. So if you have never built a design system in Angular, you know this pain, right? Control value accessing. It's very powerful, but it has a lot of boilerplate code. It's not beginner friendly, and it creates a barrier for teams that want to build reusable UI components. You implement multiple methods, you register providers, you manage change callbacks, and you spend time debugging and integration instead of building the actual UI. So with Signal Forms, you absolutely can bind a custom component using form field. And does feel great because it looks like just binding a native import. So Signal Forms replace that style of contract with interfaces. For most input controls, the interface is a generics of form value control. So the important requirement is very simple and very explicit. The component must expose a property named value, and the property must be a model signal. So Angular Signal Forms guide is very clear about this. When a component implements form value control, the form field directive binds the form's field's value directly to the value signal. So that means the boilerplate shifts from implementing a handful of callback methods to simply exposing a single property. You still write code, but the code is more direct and easier to reason about. You can literally look at the control and see where the values live. So once the contract exists, form field becomes the magic glue. And now the control participates in, validation, touch, dirty, the tracking, the disabled state, and the rest of the form ecosystem. The same way the native input does. And the real win here is not that the custom controls require zero work. The win is that the work is simpler, more explicit, and far more aligned with the signal-based mental model. So let's talk a little bit about the migration strategy. So Angular provides a migration path that lets you embed existing reactive form controls into a signal forms. So that is what Compat Form is for. It lets you do top-down migration, where the model-first structure is introduced. But you keep certain legacy controls that have complex RxJS logic or third-party integrations. So the presence of a migration API is also a signal from Angular about intent. They're not expecting a flag day rewrite. They're expecting a gradual adoption. This is also a practical answer to the questions. What if we already have a lot of RxJS-based async validation? So you can keep it, while moving your architecture towards a model-first thinking. Let's address the beginner question then. Do we really need to know RxJS well then? So this is the nuance I like to give beginners. You can absolutely use reactive forms without being an RxJS expert. And you can build a lot of forms with basic validators, simple templates, and straightforward submission. So it's not that reactive forms require RxJS in a strict sense. However, the moment you implement patterns that users expect in modern applications, like debounced async checks, autosave, conditional validation, or value-derived UI, you're very likely to reach for value changes pipelines. So in practice, RxJS becomes a hidden prerequisite for doing forms really well. And again, signal forms don't eliminate RxJS from Angular, and they shouldn't. But they reduce how often you need RxJS to express form behavior. And that is why signal forms feel easier to beginners and also less mentally taxing to seniors. So at this point, we've covered the core API, we've shown nesting, we've shown validation, we've looked at conditional UI, we've shown async checks, and shown migration. So this is now where I try to tie everything together. So reactive forms encourage you to build a control tree and then treat that tree as your center of your application. So your data comes out of it, and your advanced behavior is often expressed through streams of changes. Signal forms encourage you to define your model first and treat that model as the center. The form is a typed projection of the model, and the UI reads reactive truth rather than coordinating event pipelines. So the phrase I like to use is, signal forms move you from reacting to events to describing state. Okay. So if you take nothing else from today, take this. Signal forms feel like a natural part of your state architecture rather than a separate framework, subsystem that you have to learn and navigate. And here's some practical advice. Signal forms are still experimental, and that matters. So it means you should be thoughtful about adopting them in production, especially in large enterprises. You don't want to bet your whole platform on an API that might change. But for greenfield projects in Angular 21 and beyond, especially teams leaning into signals and zoneless strategies, signal forms are a very compelling starting point. They're also really great fit when your forms have a lot of derived UI state and conditional logic, because the model-first approach keeps the logic clean. For legacy apps, I would look at migration options like the compat form and adopt incrementally. But this is not an all or nothing decision, right? The bigger point is that Angular is signaling a direction. Signal forms show where the platform is heading. That is towards model-driven, typed, signal-based state everywhere. And to bring it back, I want to bring it back to the theme of the talk, right? Signal forms are not exciting because they remove a few lines of boilerplate. Okay? They're exciting because they change how you think. When you own your form state in a model signal, you automatically regain architectural clarity. And when the form is derived from the model, you stop juggling multiple sources of truth. And when Angular tracks dependencies, you stop building event pipelines for every little behavior, right? I don't know how often or how many times I have used value changes where I wished that there would be a simpler system. And this is where Angular signals come in. So reactive forms will continue to exist, and RxJS will continue to be an important tool, right? But signal forms make it possible to build robust forms without requiring every developer to become an event orchestration specialist. And that's it. Thank you so much.
Yes, thank you. If you have a time, we have a couple of questions in the YouTube.
Yes, I
Yeah,
have
okay.
5 more minutes or so. I'm so sorry that
Okay.
I took a
It
little bit
will be
longer,
fast.
but yeah.
Yeah. In a complex, okay, question from a Mike. In a complex Angular application with dynamic and nested forms, how would you architect signal-based form to maintain performance and a predictable state?
That's a good question. Um, I think again, when we go back to reactive forms, dynamic forms are always very complicated because you have to build dynamic form components, form groups, form arrays, things like that, right? So in signal forms, um, dynamic forms become a lot simpler because you're just inserting, I guess, properties into your type, right? I want to say hopefully your type is already restructured or structured in a way to handle dynamic properties, right? So when you work with signal forms and dynamic forms, essentially, it's very important to look at the other Angular signal APIs that exist. Computed, right? Computed effects, all of those things will help you to create a performant dynamic form. And I want to emphasize again that you need to start thinking, or you need to stop thinking in framework centric classes. That will hog you down, right? Think about the model. Think about how you can use the model to create the dynamic forms.
Okay, next question from Davron. When migrating from RxJS driven reactive forms to signals, what the key architectural trade-off and risks should be considered?
Sorry, repeat the question. When?
When migrating from RxJS driven reactive forms to signals, what the key architectural trade-offs and the risks should be considered?
Mm, Okay. So signal, like I said, signal forms don't use or don't have to use RxJS events or operators as reactive forms does, right? So the biggest risk I would say for me would be to make sure that if I have previously reactive forms pipelines that use a lot of RxJS and use a lot of event orchestration, that I don't lose the outcome from those event pipelines when converting to signal forms. And what I want to say is that, like I said, RxJS is very powerful. And with that, you can implement a lot of UI, a lot of modern UI, right? And Signal Forms isn't there fully yet because it works on a different it works in a different way. So the risk there is that you don't want to lose the functionality that you had with reactive forms when you're migrating to Signal Forms. So you have to be really mindful of that, right? Um, I'm hoping that the Angular team will be providing more APIs so that we can have um, a replacement API, I want to say, to do the things that we used to do with reactive forms, right? For example, I mentioned debounds, right? So right now, there's no direct way to debounds. You would have to do that externally, right? And Angular provided examples of how to do this the best way, right? So these are the trade-offs that you need to think about. You don't want to lose functionality, and um, you don't want to create any performance bottlenecks when you move to Signal Forms.
Okay, we can finish. Big thanks to Sonu Kapoor for this insightful session on signal forms in Angular. We explored how shifting from an event-driven pattern back to the state with the signals uh, can simplify from a management and improve a code clarity. Thanks everyone for joining. See you in the next live. Thank you.
Thank you.